Good day. I am your speaker for today, Mr. Jerome Donasco, and I will be giving you some informations about the benefits of ICT tools in our learning environment, especially in learning mathematics. We have a huge amount of knowledge to better our lives and solve difficulties thanks to technology. We can complete our tasks quickly and successfully. Technology may be used and shown to assist people of all ages as long as you know how to access it. Every year, technology gets improved and upgraded in some way. By applying physical and mental power to accomplish something that adds value. Technology takes the form of tangible and intangible attributes. A mobile phone, for example, is tangible, yet the network connection is intangible. Technology has established itself as a vital, resulting in economic gains, improved healthcare, time savings, and better way of life. So technology can help students learn more effectively. Students become more tech savvy as a result of technology. Students are more engaged as a result, and they remembered more materials as a result of the influx of newcomers. Technology is important to kids since it is continually evolving around the world. And now, I am here to discuss about the progression. So this is our topic. We will focus on the three kinds of sequence, like arithmetic progression, geometric progression, and harmonic progression. So about progression is, or a sequence is a succession of numbers in which one number is designated as the first, another as the second, another as the third, and so on is called a sequence. Each number of the sequence is called a term. We will discuss first the arithmetic progression. So what is arithmetic progression? Arithmetic progression is a sequence of numbers in order in which the difference of any two consecutive numbers is a constant value. So it is also a sequence, or progressions is defined as a sequence of numbers in which for every pair of consecutive terms, the second is obtained by adding a fixed number to the first one. There are three main terms of notations in arithmetic progression. So the common difference is D. We will write it as a D, letter D. So in nth term, the notation is A sub n. So in the sum of the first n terms, the notation is S sub n. And now, the common difference in arithmetic progression. So what is the common difference in arithmetic progression? In this progression, for a given series, the terms used are the first term, the common difference between the two terms, and a nth term. So it is supposed to be solved like this. So D equals A sub 2 minus A sub 1 equals A sub 3 minus A sub 2 equals the series. Then the nth term is A sub n minus A sub n minus 1. So example 1. This is our arithmetic progression to the 10. A sub 2 minus A sub 2 minus A sub 1, the answer is 1. A sub 3 minus A sub 2, the answer is 1. So A sub 4 minus A sub 3, the answer is 1. So the common difference of this arithmetic progression is 1. So the common difference is 1. And now the formulas. There are two major formulas we come across when we learn about arithmetic progression which is related to. First is the nth term of arithmetic progression, and second is the sum of the first n terms in arithmetic progression. So the first n term of an arithmetic progression. So the formula is a sub n equals the a plus n minus 1 times the common difference. So let's have an example. Find the nth term of an arithmetic progression. So we have the arithmetic progression 1, 3, the 5, 7, 9, and equals an. So find the n. Find the n terms if the number of terms are 8. So the number of terms are 8. So let us solve for the notation. So these are the given of the arithmetic progression. So the first term or a is equal to 1. So this is the first term. So the common difference, we subtract the second term and the first term. So the second term is 3 and the first term is 1. So 3 minus 1, the answer is 2. So the common difference is 2. And now let us solve using the formula of the nth term of an arithmetic progression. So the formula is a sub n equals a plus n minus 1 times the difference. So the notation is lately given now. So the a sub n is 8. So it is 8 equals the first term is 1. So 1 plus the nth term is 8. So 8 minus 1 times the difference, which is 2. So equals, solve first the parenthesis. So 8 minus 1 is 7. Then 7 times 2, the answer ay 8 minus 1 is 7. Dayon 7 times 2 equals 14. So 1 plus 14. So 1 plus 14 equals 15. So the 8th term is 15. So the 8th term is 15. Now for the example number 2. So find the nth term of an arithmetic progression. The sequence is 3, 7, 11, 15, 19, and a sub n if the numbers of terms is 15. So we have 3, 7, 11, 15, 19, and a sub n. So if the number of terms is 15, so the number of terms is equal to 15. So the first term is equal to 3, and the common difference is a sub 2 minus a sub 3. So 7 minus 3 is equal to 4. So the common difference is 4. Let us solve using the n term, the formula of n term. The formula is a sub n equal to a plus n minus 1 times the difference. So the a sub n is 15. So a, so 15. So the first term is 3 plus the nth term is 15 minus 1 times the difference, which is 4. Let us solve first the parentheses. So 15 minus 1. So 3 plus 15 minus 1 is equal to 14 times excuse me times 4 is equal to. Now rules of MDAS, we solve first the multiplication. So 14 times 4 is equal to 56. So 3 plus 56. 3 plus 56, the answer is 59. So our fifth term in the given arithmetic sequence is 59. And now the formula of the sum of the n terms of arithmetic progression. The formula is the sum is equals to the nth term over 2 times 2a plus n minus 1 times the difference. Example, find the sum of n terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the given is, the first term is 1. The common difference is 2. And the nth term is 15. So the formula is S equal to the n over 2 times 2a plus n minus 1 times the difference. Okay. So the nth term is 15. 15 over 2 times the first term is 1 plus 15 minus 1 and the common difference is 1. So let first solve the parentheses. So 15 minus 1 is 14. 2 times 1 is 2. So 2 plus 14 times 1. And now 14 times 1. We have 15 over 2. 14 times 1 is 14. So 14 plus 2, we have 16. 16. Okay. Just a minute. So 15 over 2 equal to 16. So 16. So 15. So 2. We suppose that we have 16 here. So 16 divided 2, we have 8. So 15 times 8. 15 times 8, the answer is 120. So our sum of the n terms in arithmetic progression is 120. The answer is 120. Geometric progression. So what is geometric progression? Geometric progression is a type of sequence where each succeeding term is produced by multiplying each preceding term by a fixed number, which is called a common ratio. The progression is also known as a geometric sequence of numbers that follows a pattern. So, we have here some examples. But before that, we will discuss first the general form of geometric progression. So, the general form of geometric progression is A is R, then AR squared, then AR cubed, then AR raised to the power 4, series through the nth term. So where a is our first term, the common ratio here is r, and a sub n is the nth term. The formula to find the nth term of the geometric progression is a sub n equals the second term n minus 1. So the common ratio, consider the sequence is ar squared, then ar cubed. So the first term is a. The first term is a. So consider this sequence. Consider this sequence. Ar squared, ar. So that sequence. So the first term is a. This is the first term. This is the first term. And this is the second term. And this is the third term. This is the third term. Example. Solve this geometric progression if the first term is 10 and then the common ratio of the geometric progression is 3, then write the first 5 terms of geometric progression. So the solution is given. So the first term is a equals 10 rather. Then the common ratio is 3. So the ratio r equals 3. Okay. Let us solve using the formula. So the first term is 10. So the first term is given 10. So we solve now for the second term, third term, fourth term, and so on. So AR this is the second term. So first term times the ratio is 3 times 3. So the answer is 10 times 3 equals 30. This is for the second term. This is for the second term. For the third term, AR squared. So AR squared. So the formula is 10. First term times the ratio 3 raised to the power of 2 equals. 3 raised to the power of 2, the answer is 9. So 10 times 9 equals 90. This is for the third term, 90. And for the fourth term, AR. So first term P, 10 times the common ratio 3 raised to the power of 3. So 3 times 3 times 3 times 10, the answer is 270. The answer is 270. That is for the fourth term. And for the fifth term, AR is the power 4. So 10 times the common ratio 3 raised to the power 4 equals. So 3 times 3 times 3 times 3, and the answer times multiplied by 10, the answer is 810. That is for the fifth term of the geometric progression. Our third progression is harmonic progression. So what is harmonic progression? It is defined as a sequence of real numbers which is determined by taking the reciprocals of the arithmetic progressions that does not contain 0. In harmonic progression, any term in the sequence is considered as harmonic means of its two neighbors. For example, the sequence ABCD is considered as an arithmetic progression. So the harmonic progressions can be written as 1 over A, 1 over B, 1 over C, or 1 over D. Somewhat like fraction. Harmonic progression formula. So the nth term of the harmonic progression is harmonic progression equals 1 over a plus n minus 1 times the difference, where a is the first term of arithmetic progression, then d is the common difference, and n is the number of terms in arithmetic progression. Example, determine the fourth term and eighth term of the harmonic progression 6, 4, and 3. So before that, this 6, 4, and 3 is the arithmetic progression. So from the example, from the definition of harmonic progression, defined as a sequence of real numbers which is determined by taking the reciprocals of the arithmetic progression, does not contain any zero. So the arithmetic progression, the harmonic progression can be written as, so this is 6, 4, and 3. So 6, 4, and 3. So 1 over 6, 1 over 4, and 1 over 3. So that is our harmonic progression. So find the fourth term and eighth term of harmonic progression using the formulas harmonic sequence. So the first term is 1 over 6. So this is the first term. 1 over 6. 1 over 6. 1 over 6 plus the nth term. The nth term we have we have fourth. So 4 minus 1, the common difference is 1 half, 1 over 12. So 4 minus 1 equals to 3. So 3 times 1 over 12 is 3 over 12, reduce 1 over 4, or reduce 1 over 4. So 1 over 6 plus, so 1 over 6 plus 1 4. The answer is, let's get the common denominator. So 4, so 6 times 2, 12. So 1 times 2 is 2. So we have 2 over 12. Then 4 times 4 times 3 is 12. 4 times 3 is 12. Then 3 times 1 is 5. So 2 plus 5 is 3 rather. 2 plus 3 is 5, then over 12. So the answer, the fourth term is 5 over 12. And now for the eighth term. The eighth term, same solution. So 1, 6, the first term, plus the nth term is 8 minus 1, the common difference is 12. So 8 minus 1 is 7. 7 times 1 over 12, the answer is 12, 7 12. So 7 12. 1 6 plus 7 12. So 6 times 2, answer is 12. Then 2 times 1, the answer is 2. So we have 2 over 12 plus 7 over 12. So 2 plus 7 equals 9 over 12. This is the eighth term of the harmonic sequence. The answer is 9 over 12. That's all for today. I hope you learned something about the benefits of ICT tools in our learning environment, especially in teaching mathematics.